Mistakes, missteps, and miscalculations. Machine learning can get tricky fast. But don't worry, we're here to make random forest as smooth as it gets. Whether you're struggling with overfitting, improper feature selection, or tweaking hyperparameters, we've got you covered. Welcome to Day 10 of our Demystifying Machine Learning Algorithms series. If you're new, don't stress. You can check out the full playlist right here and join the journey from the start. And hey, don't forget to smash that subscribe button to stay updated with every video. In this video, we're breaking down random forest and uncovering the common mistakes people make, how to avoid them. Stick around, because by the end, you'll know how to use random forest with confidence. Let's gear up with Pandas, NumPy, Matplotlib, and Seaborn, our all-star team for data manipulation, numerical operations, and stunning visualizations. Loading our dataset with Pandas. Train.csv is now ready for action. Let's quickly peek at the first few rows to understand its structure and content. Now, we're bringing in the test dataset with Pandas. Let's glance at the first few rows to see what we're working with for predictions. Now we're getting a quick overview of both datasets. We're combining the train and test datasets into one. This lets us analyze the entire data structure at once. Super helpful for pre-processing. Filling in missing values for age and fair with the median ensures our dataset stays balanced and avoids issues with null values during modeling. Here, we're visualizing the distribution of the embarked column with a count plot. This helps us quickly see how the data is distributed across different embarkation points. We're filling the missing values in the embarked column with S, the most frequent category. Now let's check our data again to ensure everything's in place. We're transforming the age column into age groups for easier analysis. Ages are categorized into bins, each representing a different age range. Let's see how this simplifies our dataset. Here, we're defining a function getTitle to extract the title from a name using regular expressions. It looks for patterns like Mr., Mrs., or Doctor, so we can easily analyze title-based trends in the data. We're extracting titles from the name column and creating a new title column. A quick value count helps us see how many unique titles we have in the dataset. We're consolidating similar titles into broader categories. Titles like Captain, Zrenia Kat Zrenia, Major, Zrenia and Rev are now grouped as Officer, while Lady, Zrenia Grafinia, Zrenia Sir, I drugi padat pod Kral. We also group Mamilel and Ems as Miss. This simplifies our data, making title-based analysis more manageable and insightful. We're handling missing values in the cabin column by filling them with missing. Then, we extract the first letter of each cabin value to simplify the data and make it more manageable. We're checking the dataset structure again to ensure everything's set. We're creating a new feature, Family Size, by adding SIB-SP and Parch together and adding one for the individual. We also create IsAlone, where passengers with a family size of 1 are marked as 1. Let's see how this looks in the first few rows. We're dropping the name and ticket columns from the dataset since they likely won't contribute much to our analysis. Let's take a look at the updated dataset. We're converting categorical columns into dummy variables with Pandas getDummies. This will make the data ready for machine learning algorithms. Let's check the structure of the transformed dataset. We're isolating the training data by filtering rows where survived is not missing. This ensures we have the complete data for model training. Let's inspect the updated dataset. We're extracting the test data by selecting rows where survived is missing. This will be used for making predictions. Let's check the structure of the test dataset now. We're splitting the data into training and testing sets with a 70-30 ratio. Features are separated from the target survived column, setting up for model training and evaluation. We're importing the random forest classifier from scikit-learn and initializing the model. It's time to train a powerful ensemble model for our classification task. We're importing Grid Search CV to tune hyperparameters and find the best model. Here, we're defining a parameter grid for Grid Search CV. This includes testing different values for NO estimators, criterion, max features, max depth, min sample split, and min weight fraction leaf. By tuning these, we'll optimize our random forest model to achieve the best performance possible for the task at hand. We're setting up Grid Search CV with the random forest classifier, applying our parameter grid, and using threefold cross-validation. This will help us find the best hyperparameters for our model. We're training the random forest model using Grid Search CV to find optimal hyperparameters. We're accessing the best model from Grid Search CV after tuning. We're initializing a random forest model with optimized hyperparameters, using entropy for criterion, a max depth of 590 estimators, and other tuned settings for better performance. We're training the random forest model with the training data, then making predictions on the test set. Let's see how well our model performs with these predictions. We're printing the accuracy scores for both the test and training datasets. This helps us compare how well the model generalizes on unseen data versus how it performed during training. We're checking the test dataset to confirm its structure and content. We're preparing the test data for prediction by dropping passenger-eyed and survived columns, then using our trained model to make predictions and converting them to integers. We're creating a submission data frame with passenger-eyed and the predicted survived values, ready for submission. Let's check how the final output looks. We're saving the predictions to a CSV file, rfclasssubmissions.csv, without the index. so it's ready for submission or further analysis. And that's a wrap on mastering random forests. You've seen how to fine-tune, train, and make predictions with this powerful model. But don't go just yet. In the next video, we're diving into K-nearest neighbors, KNN, and how it can elevate your classification game. Click on the screen to continue watching.